Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are going to discuss about the Bsc Physics second year paper 4, Waves and Optics. The title is Waves and Optics. That one, what are the exam questions will come in your exam? Those questions we have to discuss. Clear? Once again you have to see Bsc Physics second year paper 2, Bsc Physics second year paper 4, this is the even semester, Waves and Optics, Bsc Physics second year paper 4, Waves and Optics exam strategy, that is a theory exam strategy. Because initially after 1 year there is exam is there, so much of plenty of time is available to read the chapters and to revise the chapter. There is a tests are there, unit test and free finally, quarterly, half yearly, like the tests are there. Then annual exam is there. But now there is no scope like that. Directly this is a semester examination. Within 3 months you have to write the exam. You are unable to aware about the syllabus, right? So syllabus also sometimes won't complete your teacher, but even though you have to attempt the exam to get the marks. How we have to get the marks? There is a strategy is there. To get the rank, to get the marks, there is a strategy there. You don't want to read entire the syllabus. So we have to read, what to get in exam. That is very, very important. Clear? Once we have to see. Bsc second year semester 4, paper 4. The title is Waves and Optics. 1 unit is belonging to waves and 3 units belongs to the optics are there. First you have to see the first unit belongs to the waves. There syllabus once you have to see fundamentals of waves. You know the wave. What is the wave equation? How we have to represent the wave equation? What is the displacement? What is the amplitude? What is the velocity of the wave? What is the acceleration of the wave? So those things you have to learn in fundamentals of waves. Clear? Next, transverse wave propagation along a stretched string. This is the first part. There is a stretched string is there. You have to take the string and you apply the force. What will happen? That string should be vibrate. Clear? That is a wave should generate. That general solution of the wave equation and writes its a significance of the stretched string. Next, modes of vibration of a stretched string, clamped at the ends, overtones, energy transport, transverse impedance. This is the first part. Which part it is? This one is a first part, right, in unit number 1. The second part, two parts are there. One is the longitudinal vibration of the bars and the second one is the transverse vibrations of the bar. This entire thing is a second part only. Longitudinal vibrations in bar, wave equation and its general solution. Special cases, bar fixed at the both ends, bar fixed at the midpoint, bar fixed at both ends, bar fixed at one. Like that questions will come. Transverse vibrations in a bar, wave equation and its general solution, boundary conditions, clamped free bar, free bar, bar supported at both ends, tuning fork. These are the two parts are there. Majorly in the first unit only waves. That waves, only two types of waves are there. One is belongs to the stretched string. One more is belongs to the bar. What is the bar? In your first year laboratory, you have to take a compound pendulum, no? Compound pendulum bar. That is a bar. So once you have to vibrate, there is a longitudinal vibrations can form. Otherwise, you have to see a transverse vibrations also will form from the bar. Clear? Once you have to see the important questions in the first unit. Describe the energy transport in a stretched string. you have to write the energy transport of the stretched string equation. That is the first question. Next, explain briefly about the tuning fork. This is also second question. You will get it. Tuning fork. Important. Explain overtones. First overtone, fundamental tone, first overtone, second overtone. Like that, the overtones, how it will be formed. Those things you have to explain. Next, derive the velocity of transversive waves in a stretched string. What is the velocity of the transversive wave in a stretched string? You have to derive. Describe the transversive impedance of a stretched string. Transversive impedance is equal to how much? How many questions I make it? 5 short questions I made. So 5 short answer questions from unit number 1. Once again you have to see. The first question is describe the energy transport in a stretched string. Explain briefly about the tuning fork. Explain the overtones. Derive the velocity of transversive wave in a stretched string. Describe the transverse impedance in a stretched string. Clear? These are the 5 short questions. Each and every unit 5 short questions and 5 long questions I made. Total 40 questions I made. Right? Once you see the long question. Obtain the wave equation and its solution for a stretched string. Stretched string wave equation and writes its the central solution. This is very important. Explain the modes of vibration of a stretched string and writes its laws of transversive vibration of a stretched string. This is very important. Laws of transversive vibration of a stretched string. Sometime it will come under the short question also. This is the second one. These 2 questions from part 1 only I gave. You have to read these 2 questions. Rest of the 3 questions you overlook also, no problem. Obtain the wave equation and its solution for a longitudinal vibration of a bar. Longitudinal vibration of a bar. Next, same question you have to see. Obtain the wave equation and its solution for a transversive vibrations of a bar. This is the transversive vibration. Third one is a longitudinal vibration. Clear? The fifth one, explain the boundary conditions for a transversive vibrations of a bar. Give its solution free bar. Free bar solution. One condition I am giving. So these are the important questions, long questions from unit number 1. 2 long questions are there from first part, that is a stretched string. 3 long questions are there from the second part. 3 long questions are there from the second part. You have to read these 5 questions. Pakka you will get 20 out of 20 marks. This is the long answer. No? For each and every unit 20 marks weightage is there. If you read these 10 questions, you will get the 20 out of 20. Now I am coming into the second unit. So what is the second unit? This unit starts with the optics, right? In optics, 3 phenomena are there. One is interference. The second one is the diffraction. The third one is a polarization. Clear? So now I am seeing about the interference. The second unit belongs to the interference. First, how interference pattern can form. So principle of superposition is there. Which one is there? Principle of superposition. You have to take a principle of superposition. Coherence. There is a 2 types of coherence is there. Temporal coherence and spatial coherence. Condition for interference of light. This is one part. Right? One part you have to take. This is the basics of the interference. To get the interference, that light should be coherent light. To get the conditions of the interference, coherent light must be there. Next, interference, 2 varieties of interference is there. One is division of wavefront. Another one is division of amplitude. Interference, division of wavefront. Interference due to the division of amplitude. In wavefront, there is a Fresnel biprism, determination of wavelength of light, determination of thickness of a transparent material using the biprism. Next, change of phase on reflection, Lloyd's single mirror experiment. change of phase on reflection, and Lloyd's single mirror experiments are there. This is the second part in the second unit. Now, interference by division of amplitude. There is a oblique incidence of the plane wave in a thin film due to the reflected and transmitted light. That is cosine law. Cosine laws you have to get it. Colors in films, non-reflecting films, interference by a plane parallel film illuminated by a point source, interference by a film with two non-parallel reflecting surfaces. This is very important. Wedge-shaped film. Determination of the diameter of the glass plate. Newton rings. This one is very important. Transmitted light, Heidegger fringes. Determination of the wavelength of monochromatic light. Next one is a Michelson interferometer. In Michelson interferometer, types of fringes, determination of the wavelength of monochromatic light, difference in wavelengths, that is sodium D1, D2 lines, and thickness of a thin transparent plate. This is the syllabus. This one is a third part in the second unit. A little bit big unit is there. You are unable to read within 2-3 days. You have to exercise it. Then only you will get the good idea. Write a brief note on non-reflecting film. What is a non-reflecting film? You have to write the brief note. That one is a first short question. Write the condition for interference of light. This is very important. So many times question came this one. Write the condition for interference of light. Describe about the Lloyd's single mirror experiment or phase change on reflection. You have to take a phase change on reflection also. Phase change on reflection. Lloyd single mirror experiment can works based on the phase change on reflection. This is also important. You have to read this one also, because Lloyd single mirror experiment based on this principle only. Distinguish between the temporal coherence and the spatial coherence. This is very important, right? Write a brief note, colors of thin films. Colors of thin films you have to write. These are the 5 questions I make it. Among the 5 questions, 3 you will get in your competitive examination, your theory examination. So please concentrate. How many questions? 5 questions. Question number 1, write a brief note on non-reflecting films. The second one is write condition for interference of light. The third one is describe about the Lloyd single mirror experiment or phase change on reflection. Phase change on reflection. This is also important. Write a brief note on colors of thin films. These are the 5 short questions you should learn. So these are only 5 short questions you have to learn. Now I am coming into the long. Discuss about the Fresnel's biprism. Fresnel's biprism structure you have to write, and write the expression for the thickness of a transparent material. You have to use a transparent sheet. The thickness you have to find by using the Fresnel's biprism. That is the first question. Second one you have to see. Derive the cosine laws. Maybe you have to take 2 varieties of the cosine laws. One is due to the reflected light, and another one is due to refracted light. Due to the reflected light and due to refracted light. Both cosine laws you have to write. This is very important. The third one is explain the interference by a film with 2 non-parallel reflected surfaces and determine the diameter of the wire. This is nothing but wedge-shaped film. Wedge-shaped film. Using the wedge-shaped film, so we are finding the diameter of the wire. Whatever the wire, if you have to use your air, that air diameter also we have to find. This is very important. Third one. Already this question came in the last time. Now fourth one, explain the Newton rings experiment and determine the wavelength of monochromatic light. Find its wavelength of a monochromatic light. In your laboratory also you are learning the Newton ring. That one you have to write. The fifth one is discuss the working of Michelson interferometer. Maybe in your first year also you are learning the Michelson interferometer and write any one of its uses. Any one of its uses. 3 uses are there according to your syllabus. What is there? To determine the wavelength of light, difference in the wavelength of sodium lights D1, D2 and thickness of a thin transparent plate. 3 applications are there. Among the 3 applications, you have to write any one of application. These are the 5 long questions. Once again, you have to see the first one is a Fresnel biprism. 5 long questions I am making. The first one is a Fresnel biprism and application of the Fresnel biprism. The second one is a cosine loss due to the reflected and refracted. The third one is the explain the interference by a film with 2 non-parallel reflecting surfaces and determine the diameter of the wire, that is nothing but wedge-shaped film. The fourth one is explain the Newton ring experiment and determine the wavelength of a monochromatic light. The fifth one is discuss the working of Michelson interferometer and write any one of its uses. 3 uses are there. What are the 3 uses? First one is to determine the wavelength of light. Second one is to difference between the wavelengths, sodium light wavelength D1 and D2. The third one is to determine the thickness of a film, right? So sodium lamp, 2 wavelengths are there, that is 5890 angstroms, 5890 angstroms. This is the D1 line. That 5896 angstroms, that one is a D2 line. So 2 wavelengths are there. That wavelengths difference you have to find out, delta lambda. Clear? So now I am coming into the unit number 3. Unit number 3 also belongs to the optics only. This is the another phenomena of light. What is the another phenomena of the light? Diffraction. Diffraction is very, very important. Introduction and distinction between the Fresnel and Fraunhofer diffraction. This is very, very important. As a short question, pakka you will get first short question only. This is the first part. Introduction of the diffraction, distinction between the Fresnel and Fraunhofer diffraction. The second one is Fraunhofer diffraction. The second one is Fraunhofer diffraction due to the single slit, circular aperture, limit of resolution. Fraunhofer diffraction due to the double slit. Fraunhofer diffraction pattern with N slit. That N slit is nothing but a diffraction grating. Clear? Now, the third part is resolving power of grating. Determination of wavelength of its normal and oblique incidence method using the diffraction grating. The fourth one is, what is the fourth one? Fresnel diffraction. Fresnel's off-period zones, area of the off-period zones, zone plate, comparison of the zone plate with convex lens, phase reversal zone plate, diffraction at a straight edge, diffraction between the interference and diffraction, difference between the interference and diffraction. How many parts I segregated? Total 4 parts I segregated. One is introduction, another one is Fraunhofer diffraction, third one is grating, resolving power of grating, the fourth one is the Fresnel diffraction. Now we will see the questions, how the questions will come in the third unit. First, write the distinction between the Fraunhofer and Fresnel diffraction. This is very, very important. Fraunhofer diffraction and Fresnel diffraction differences you have to write. Explain the intensity distribution of a Fraunhofer diffraction due to the double slit. Due to the double slit, what is the intensity distribution? That formula you have to write. Define the resolving power of grating. What is the resolving power of grating? You have to write. Distinguish between the interference and diffraction. This is also very, very important. 2 variety of difference is there. One is Fraunhofer and Fresnel diffraction difference. Another one is interference and diffraction difference. Write the comparison between the zone plate and convex lens. What are the comparisons? Zone plate can act as a convex lens. So how many comparisons are there? You have to compare. This question also come as a short question. So these 5 questions I made as a short questions, right? So these 5 questions you have to read, that is enough for you. Write the distinction between the Fraunhofer and Fresnel diffraction. Explain the intensity distribution in Fraunhofer diffraction due to the double slit. Define the resolving power of a grating. Distinguish between the interference and diffraction. Write the comparison between the zone plate and convex lens. Clear? Now, I am coming into the long questions. Explain the intensity distribution of a Fraunhofer diffraction of grating. Fraunhofer diffraction of grating means n number of slits. N number of slits per inch 2500 or 15,000 slits are there. So that is a grating. Already in your laboratory also you are doing this experiment. This is very, very important. That intensity formula you have to derive. Describe the Fraunhofer diffraction due to the single slit with the necessary theory. Discuss the intensity distribution. This is a 2 questions I made from Fraunhofer diffraction only. Second part. Now you have to see the third question. Determine the wavelength of light in normal and oblique incidence method using the diffraction grating. This is the third one. Diffraction grating, normal and oblique incidence. In the laboratory also this experiment is there. Explain the Fresnel's off-period zones with necessary theory. You have to explain the Fresnel off-period zone theory. Area, radius, everything you have to find out. Next, derive the focal length of zone plate. Zone plate focal length you have to derive. And explain the phase reversal zone plate. Phase reversal zone plate also you have to explain. So these 5 questions are very, very important. These 5 questions you have to read as a long answer question. Long answer question. Explain the intensity distribution of Fraunhofer diffraction of grating. Describe the Fraunhofer diffraction due to the single slit. Double slit I made in short. Single slit I made in long. Right? Determine the wavelength of light of a normal and oblique incidence of a diffraction grating. Explain the Fresnel's off-period zones. Fresnel's off-period zones very, very important. Derive the focal length of zone plate and explain the phase reversal zone plate. These are very, very important questions. Above 10 questions you have to read. You will get out of 20 marks you have to get in this unit. Now I am coming into the last unit. This is also another phenomena of the light. What is the light phenomena? Polarization. Right? Once you have to see the polarization, polarized light. How we have to get the polarized light? There is a methods are there. Polarization methods. Polarization due to the reflection one method, due to the refraction one method, due to the double refraction another method, the selective absorption is another method, scattering of the light. How many methods are there? Due to the reflection, due to the refraction, due to the double refraction, due to the selective absorption, and the fifth one is the scattering of light. Through 5 phenomena, we have to make unpolarized light into a polarized light. These are very, very important. Next, Brewster's law and Malus law also come under these phenomena only. This is a first part. First part, there is a 5 polarization methods are there to make the unpolarized light to polarized light. Now the Nicol prism. Nicol prism can act as a polarizer and analyzer. Refraction of plane wave incident on negative and positive crystals. Huygens explanation theory. This is very, very important. Quarter wave plate, off wave plate, Bobinette compensator. This is another part. Optical activity, analysis of light by Lorentz off-shaded polarimeter. This is also important one. So entire the 4th unit. This one is the first part. You have to take it as this one is the second part. Now you have to take optical activity is the third part. Now once you have to see the questions, how the questions will come in your examination. Write a short note on positive, negative crystals. What is the positive crystal? What is negative crystal? Give the examples you have to give. This is a very, very important. Write a short note on positive and negative crystal. Define the Brewster's law. Define the Malus law, right? What are the quarter wave plate and half wave plate thicknesses? You have to explain. Define the optical activity. These are 5 questions you will get as a short answer question. These are very, very important. First one you have to say, write a short note on positive and negative crystals. Define the Brewster's law. Define the Malus law. What are the quarter wave and half wave plates? Define the optical activity. Clear? Right. Next, long questions you have to see. Write about the polarization methods. Already I told no, 5 polarization methods are there. One is due to the reflection. Another one is due to the refraction. The third one is due to the double refraction. The fourth one is a selective absorption. The fifth one is the, so what is the fifth one? The fifth one is scattering of the light. So these 5 methods you have to write. Is a long question. Describe the working of Nicol prism. Nicol prism can act as a polarizer. Nicol prism can act as a polarizer and analyzer. How we have to use a polarizer and analyzer, you have to explain. Discuss the Huygens theory explanation for positive and negative crystals. So for positive crystal and negative crystal, Huygens theory explanation you have to write. This is very, very important question to analysis the polarized beam. Right. Next, fourth one, explain the analysis of light by Laurent off-shaded polarimeter. Laurent off-shaded polarimeter. In your laboratory also you are learning this experiment, correct? So the same story you have to write there also. Laurent off-shaded polarimeter is there, how it will work, how you have to calculate the specific rotation there, you write. Next, fifth one, discuss the working of Bobinette compensator. Bobinette compensator, why we need the Bobinette compensator? Already we learned about the Nicol prism. What are the overcomes are there in Bobinette compensator? How it is working? So what are the advantages of the Bobinette compensator? Bobinette compensator can work as a quarter wave plate. Bobinette compensator can work as a half wave plate. Like that it can work. What are the examples you have to give? So these are the 5 questions you have to see. These 5 questions, long answer questions. Once again you have to see, write about the polarization methods. Those are 5 methods are there. Describe the working of Nicol prism. Discuss the Huygens explanation for positive and negative crystals. Explain the analysis of the light by Laurent's off-shaded polarimeter. Discuss the working of Bobinette compensator. Clear? So these are the 10 questions you have to read. You will get 20 out of 20 marks in this unit. These are the 4 units are there. What are the books? So according to your syllabus, so many reference books are there, but you have to take any textbook or any question bank. Otherwise, second year physics Telugu Academy. Second year physics Telugu Academy, you will get second year physics Telugu Academy, you will get second unit and third unit and fourth unit you are getting in the optics and thermodynamics is there, but optics is there in your second year. So that's why second year Telugu Academy book you have to take. Otherwise, unified physics second year also you have to take. Unified physics second year also you have to take. There you will get the second, third and fourth. First, waves you are getting in different book. Waves and oscillations are there. One book, that is a first year book you have to get, but entire portion is not there. Only two subtopics are there. One is stretched string, another one is the vibrational bar, and longitudinal bar is there. Clear? Right. So you have to prepare, or any test paper you have to take, and these questions you have to prepare. You will get the maximum number of marks. So thank you for listening our exam strategy. So you have to read these questions. You will get the benefited in your examination. All the best. Take care. Thank you. Bye bye.